All right, so we're back to look at some problems about finding the center of mass for an area that's between two curves. Here are the formulas for that, right? The x bar now has been changed, so instead of just x f of x, it's x times f minus g, and instead of just a half f of x squared, it's a half f of x squared minus g of x squared. Okay, let's look at problem 6 on the handout here. Let's see here. Problem 6, we're working with y equals square root x and y equals a half x. So those two functions are going to do this and this. And that point of intersection is the point where the square root is equal to half the number, or the point 0.42. All right, so now we need to know this area in between those two curves. So we want to find the integral from 0 to 4. The top one is the square root function, and the bottom one is the linear function. So this is going to be x to the 0.5 minus a half x dx, or 2/3 x to the 1.5 minus 1 over 4 x squared from 0 to 4. Okay, so let's see what we get here. So this will be 2/3. 4 to the 3/2 power, that should be 8. And then 1/4 of 16, and then minus 0. So this will be 16/3 minus 4. So what is that? 16 minus 16/3 minus 12/3, or 4/3. Okay, so that's our area. So now, if we want to find x bar, that's going to be the reciprocal of the area, okay, which in this case is 3/4. And then we want to integrate from 0 to 4, x times x to the 0.5 minus a half x. Okay, and now we've got to distribute inside there before we can do this integral. So that'll be x to the 1.5 minus a half x squared. And now we have to do the integration. Okay, so this will be x to the 2.5 over 2.5, or times the reciprocal of 2.5, which is 2/5. And then minus 1 over 2 times x cubed over 3. And then we want to evaluate that from 0 to 4. Okay. So let's see here, 3/4, and then, so 4 to the 5/2 power, I think that's going to be 2/5 times 32. Okay, and then minus 1/6 times 64. So let's see what we get out of this. So this is 64 over 5 minus 64 over 6, and so that's going to be 32 over 15 times that 3/4, so that's 8 over 5, or 1.6, however you want to think about it. Okay. All right. That's our x bar. Let's see, I think I'm going to erase the area. I'll write it down first. Our area in this problem was 4/3. So now let's erase that. And now we want to find y bar. Y bar is going to be 1 over a, which is 3/4, times a half, integral from 0 to 4, f squared minus g squared dx. Okay, so that'll be 3/8 integral, that's just going to be x, That'll be 1/4 x squared dx. So what do we got here? This is x squared over 2. This will be x cubed over 3 times 1/4, or 1/12 x cubed. All right, so what do we got here? 3/8 times 16 over 2, which is 8, and then 64 over 12, which is 16 over 3. Let's see here. Yeah. So this is going to be 3/8 times 8 minus 16 over 3. This is 24 over 3. This actually ends up being 1. Okay? This piece right here is 8/3 times the 3/8, and so our y bar is 1. And so let's see, does that make any sense at all? If this is 4, 2, and this is 2, so this is 1. All right, our x bar is 1.6 right about here. Our y bar is 1. And yeah, that puts us in a pretty good place for the center of mass for that figure. Okay. All right, so that's problem 6. Now I'm going to have to erase all of this. I'll leave those formulas up there. Let's see here. All right. Now, problem 10 is x to the 2/3, so here's problem 10, y equals x to the 2/3, and y equals 4. Now this is one that I myself had to graph on the graphing calculator. That x to the 2/3 function looks something like that, and then the y equals 4 is right about there, y equals 4. And this is the point 8,4, and this is the point -8,4. Okay? All right, so if you just look at this figure, you should see that the x bar is going to be 0. I mean, I was calculating it and I was getting an answer of 0, and then I realized, oh, of course, right? Of course, the center of balance for something that's symmetric like this is going to be right in the middle. Now, the y bar is going to be a little bit more interesting. Okay, that's going to be up in here somewhere. We'll figure out where that is. But let's go ahead and go through the calculations for this. Our area is going to be the integral from -8 to +8. Now be careful, because in this one we're not integrating from 0 to something. We are going to have to plug in both of these limits of integration. And this is technically the area between two curves, right? Because it's between the y equals 4 and the y equals x to the 2/3. So this is going to be 4 minus x to the 2/3 power dx. All right. So if we integrate there, we'll get 4x minus, so this will be x to the 5/3 over 5/3, which is times 3/5. And then we want to evaluate this from -8 to +8. So this is 32 minus 3/5 times 32. And then we want to subtract -32, and then that'll be plus 3/5 times 32. So what do we get out of this for the area is 64 minus 3/5 times 64. Let's see here. That area should be 128 over 5, or as a decimal, it's 25.6. So let's see whether we get that. 25.6. And so we turn it into a fraction. And you don't have to turn it into a fraction if you don't want to. I happen to like doing that. 128 over 5. And so when we come over here to do 1 over a, I'm going to use 5 over 128. If you just want to do this, there's nothing wrong with that. You know, that works just as well. And in fact, I'll just leave it like that, and we'll make our calculations based on that. All right, so there's 1 over a. Then we want to integrate from -8 to +8. X times f is 4, g is x to the 2/3. Okay, let's see here. So 1 over 25.6, -8 to +8. That'll be 4x, and then x to the 5/3. We want to integrate now, so this will be 2x squared. So that'll be x to the 8/3 over 8/3. And then we want to evaluate this between -8 and +8. So 1 over 25.6. So this is 64 times 2, 128, minus 3/8 times, I think that's going to be 256. 8 to the 8/3 power, 256. And then minus, let's see, that's going to be 128. And then, let's see here, -8 to the 8/3 is also going to give us 256. So that'll be minus 3/8 times 256. And notice how this all cancels itself out, right? 128 minus 128, negative this will make this one positive. This is 0. And so when we multiply it by 1 over 25.6, we still get 0. And I talked about that a few minutes ago. Okay, so that's not quite as interesting. But the y value, I think, kind of is interesting. So let's go ahead and do that. Let's see here. All right, so y bar, 1 over 25.6, and then a half. -8 to +8, f squared, so that's the 4, and then g squared is the x to the 2/3 all squared. All right, so there's our integral, and what is this going to be down here, 51.2? Okay, so 1 over 51.2. Integral -8 to +8, 16 minus x to the 4/3 power. Okay. So that'll be 16x minus, so this will be x to the 7/3 over 7/3. From -8 to +8. I left out my x there. There we go. Okay, so 1 over 51.2. 8 times 16 should be 128. And then, let's see, 8 to the 7/3 is, I believe, going to be 128, right? 8 to the 7/3. 128, so that's 3/7 times 128. And then we're going to subtract, let's see, -128. And then if we do -8 to the 7/3, that'll be -128. So those will be positive. But of course, this is going to make it negative again. So this comes out as 256. And then minus 3/7 times 256 times 1 over 51.2. So 256 minus 3/7 times 256. And we get something that is in the sevenths. Okay, it's about 146.3 or so. But what it really is 1,024 over 7. And if we multiply that by 1 divided by 51.2, we get about 2.857. But as a fraction, that's 20 over 7. Okay, and so that's a little bit short of 3, right? This is y equals 4, 3 is up here, and so that puts our center of mass right about there. Like I said, the x bar is 0, but the y bar, because most of the area is up here, so it makes sense that the center of mass on the vertical axis is closer to the top than the bottom. Okay, well, we'll have one more handout for center of mass. I'll make another video and another quiz to go along with that, and then it'll be time for the midterm. So we'll get going on that soon enough.